Have a look at example number 9 now. This relates to example number 8 that we did yesterday. It says, how far has the car in example number 6 traveled during its time of acceleration? This is acceleration still, so we know it's going to be group B, one of those 5 equations. Let's write down our givens again. Now, if I was doing this right after I did the previous question, I would not write down my givens again because I'd have them right there, right? I'm just doing it because we're one day removed from having done question number 8. Okay? It's not necessary, if you have 2 questions in a row that use the same givens, it's not necessary to write down the givens, the same givens, twice. I won't take marks off for that. What do we have here? We had VI was 10 meters per second. What else do we have? Speeds up to 25. We're going to say VF was 25 meters per second. And my time interval was 6 seconds, I think it was. Yep. We solved for the acceleration of the car in number 8, right? What was it? 3.5? 2.5? Let's write that down as another given. Why not? Why can't we use that, right? Now, having said that, we could get away without using this. Here, I'm going to write this down in a different color here. You'll see why in a second here. We could do this in a couple of different ways. We could say D is equal to VI plus VF over 2 times T and not use the acceleration, right? VI is 10, VF is 25 over 2 times 6 is 35 divided by 2 is 17.5. 17.5 times 6 is, what is it? 90? No. 15 times 6 is 90. 15 times 6 is 90. 2.5 times 6 is 15. So 105. 105 meters, although, we would round it to 1.1 times 10 to the 2 meters because it should be 2 significant figures, right? That works, right? Now, because we have the acceleration, we're allowed to do it a different way, too. You can choose whichever way you want. Let's pretend I did not do it that way. Let's pretend I didn't get an answer for this. You looked at VI, VF, T, and A, and you want to solve for D. What's another option? You got a lot of options at this point. You could say D is equal to VIT plus 1/2 AT squared. Watch this. Watch me do this here now, guys. This gives me 10 times 6 plus 1/2 of 2.5 times 6 squared. Let's calculate that. 10 times 6 plus 0.5 times 2.5 times 6 squared gives me 105, or 1.1 times 10 to the 2 meters. Or given the acceleration that I just found, maybe I want to try, I want to solve for D here. Maybe I want to try D is equal to VFT minus 1/2 AT squared. What do you think I'm going to get when I do this? Better, right? The final velocity is 25 times the time interval here is 6 minus 1/2 of 2.5 times 6 squared. Let's say 25 times 6, subtract, bracket, 0.5 times 2.5 times 6 squared gives me 105. 1.1 times 10 to the 2 meters. Now, I'm not going to keep going with this. There are other options. VF squared is equal to VI squared plus 2AD would work. We just have to rearrange it to solve for D, all right? And that's kind of a tricky one to rearrange. But you see that sometimes we do have more than one option, right? Especially when we've solved for something else, like acceleration that we did in the first example question. Good?